All right, this is topic 27.4. This is the last lesson for geometry. Yay! Today we're going to look at the effects of changing one or more dimensions of a figure and how that changes the perimeter, the area, and the volume. So far we've looked at similar figures. So what if they're not similar? How does that affect the perimeter, the area, and the volume? And so here's a picture of a cube. And when we were looking at similar solids, we would compare this with another cube. But what if you just changed one dimension? So for example, if we change the height, or what if we just changed the width? So these are things that we're going to explore today in our lesson. So the first thing we're going to do is look at this rectangular prism, and you'll notice that the prism starts off with a height of 1, then a height of 2, and then 3, and then eventually it goes to h, which means it could be anything. So let's go through and find the surface area and the perimeter for each one. So for the first one, we know that to find surface area, it's 2 times big B plus pH, which is your lateral area. This is lateral area. This is the area of your bases. So for the first one, your base is, we'll say the bottom one. So this is going to be 2 times the area of your base, which is 4 times 2, plus the perimeter of your base, which is 4 plus 2 plus 4 plus 2. So that's going to give you 12. And then your height is 1. So that's 8 times 2, so that's 16 plus 12, which equals 28. So the surface area of this prism is 28, and that's square units. The volume is just length times width times height, so that's just 4 times 2 times 1, so that's just going to be 8 cubic units. All right, for the next one, we've doubled the height, so you see the height got doubled. So if we find the surface area, that's 2 times the area of the base plus the perimeter times the height. The base is the same, so this part stays the same, and the perimeter stays the same. It's the height that's changing. So this is going to be 16 plus 24, which equals 40. So 40 square units is going to be our surface area. And then for your volume, it's just 4 times 2 times 2, which is 16. So what we noticed is that when the height changed, that was the only dimension. And the volume, this doubled, and look, the volume doubled. When we compare the surface area, if we look back over here, the area of the bases stayed the same, but it was this part that doubled. And remember I said this is the lateral area. So the lateral area doubled, and of course the bases are staying the same. Now let's see if it has that same effect if you triple the base. So if we compare it to this one and we triple the base, or the height, sorry. So this is 2 times big B plus pH. Again, this part is all going to stay the same, so I'll just put 16, plus the perimeter is still 12, but the height now is 3. So this is 16 plus 36, which is 52. And that's square units. So again, we can see that we start off with a lateral area of 12, and by tripling the height, we also tripled the lateral area. For the volume, it's just 4 times 2 times 3, which is 24. So we can see that the volume tripled also. Now, what happens when you just change the height? Well, we said that the lateral area is what's going to change. And so when we look at this, our surface area is what's changing each time. So this we could replace with h. So we have 16 plus 12h. Now up here it says 12h plus 16. That's the same thing. But this is that lateral area. And our volume, we just took the original volume and multiplied it by the scale factor, which is what your height was changing by. So this is just 8h. So for question 2, it says, how are the surface area and the volume changing as the height changes in the table? Okay, well, your volume changes by a factor of the scale factor. Which just means if your scale factor, whatever your scale factor is changing by, is how your volume is going to change. So if it triples, then the volume's tripling. If it quadruples, then the volume's quadrupling. The surface area, it's the lateral area changes by a factor of the scale factor. Because the base is staying the same, so it's not going to change. Now, if we take this cube and it says, again, we just change one dimension, okay? It says, what would be the resulting solid? Well, if we just change one end, now we're going to have a rectangular prism. And again, the volume's just going to change by a factor of x, and then the lateral area will change by a factor of x. Now, let's look at some examples. So here's our first example. It says, a can for a new energy drink is being designed. The can will be in the shape of a right cylinder. The original design calls for a can with a diameter of 6 centimeters and a height of 10 centimeters. Now the company wants to design a can that is twice as tall that will hold the same amount of the energy drink. Which of the following statements is true about the old and the new design? This is the key part right here. It will hold the same amount. Okay, that is the volume, which means we want our can to have the same volume as the original can. So when we look at our choices here, our cans are going to have congruent volumes. So A is our correct answer. They are not similar because you're only changing one of the dimensions. You're doubling the height, not the radius. The cans are not congruent. We know that because we just said that you made it twice as tall. And it says the can is twice as big as the old can. Well, the volume of it is what's the same. We don't know if it's going to be twice as big or not. All right, let's look at the next example. So same can, okay. We have their energy drink. It's a right cylinder. The diameter is 6 centimeters and the height is 10. And it says, but the owner, he doesn't like the size, or she doesn't like the size. She wants to design it so that it will hold half of the amount of the energy drink as the original one, but have the same height. And so what would the radius be? All right, so let's take a look at this. Make this a little bit bigger. All right, let's figure out what the volume is of this original one. So if it has a diameter of 6, then it's going to have a radius of 3. So R is going to be 3, and we know the height is 10. So our volume is pi times 3 squared times 10, which is 90 pi cubic centimeters. Now, I want my new one to have half of that and the same height. So half of 90 pi is 45. And my height is going to be 10, and I don't know the radius. Okay, so let me move up here. We know that the volume is going to be 45 pi. We don't know what the radius is, and the height is 10. So when we plug it into our formula, volume equals pi r squared h. The 45 pi goes over here, and I don't know what r squared is, and of course the h is 10. So your pi's cancel, you divide by 10, so r squared equals 4.5. Now you'll notice that's one of your choices. Well, not really, sorry. I thought it was. That would be a good one to put because that would be a distractor. Now we just have to take the square root. And so the square root of that is 2.12 centimeters. So C would be the correct answer. We just changed the height. So that's just changing, or we left the height the same. We changed the volume, and so the radius is going to change. All right, number 6 says, Monique compares two trapezoidal prisms. Their bases are congruent, but their heights, the height of the first prism is 6 centimeters, and the height of the second prism is 15 centimeters. What is the relationship between the volume of the two prisms? All right, so if we think about our formula for a trapezoid, okay, so you have volume is big B times H. So H is what we're changing, which in this case is just this one dimension, okay? And so since we're just changing that one dimension, this scale factor is going to have the same effect with the volume, okay? So if we compare the two prisms, the second prism is 15 centimeters. That's your image. So if we did 15 over 6, we get 2.5. So that means that the height was multiplied by 2.5. So if we plug that in here and to compare it to the original volume, the volume would also be 2.5 times the original one. So B would be the correct answer. So what we did is we compared this, and since this was the only dimension that we changed, then, and that's not squared or cubed, then that's going to have the same effect on the volume. Okay, number 7 says that you have a cylinder that has a radius of 4 units and a height of 19, but you decide to cut the radius in half and keep the height the same. How will this affect the volume? All right, so let's think about our formula for a second. Volume for a cylinder is pi r squared h. So what we are wanting to do is take the radius and cut it in half. So let's look at this right here, this r squared. Okay, so we want to replace this r squared with 1/2 r. So we're going to have pi times 1/2 r squared times h. That's going to be our new volume. And when we square this, because this is the r is squared, that half is also going to get squared. So we're going to get pi times 1/4 times r squared times h. And when you pull that 1/4 out in front, this is just your volume. So it's 1/4 of the volume. So the new volume is going to be 1/4 of the volume before the radius was shortened by 1/2. All right, the last one. We've got two triangular prisms. Their heights are shown, and it says that the height of the first one is 5 centimeters and the height of the second one is 15 centimeters. Okay, and it tells us the volume is 10 centimeters, cubic centimeters for the smaller one. So we're trying to figure out the volume of the larger one. Well, again, because we're only changing the height, the scale factor that we're changing it by is going to have the same effect. If we go back to the notes, the volume changes by a factor of the scale factor. So our scale factor is going to be 15 over 5, which is 3. So this one got 3 times, the height got 3 times bigger, which means your volume is going to get 3 times bigger. So 10 times 3 is 30. So the volume of this is 30 cubic centimeters. And you can see that here. And then here's your explanation. Again, it talks about the height. That's the only dimension that you're changing. So the height's going to be 3 times bigger, which means that your volume is going to be 3 times bigger. All right, real quick, because I'm about to run out of time. If you distort just one side, if you do them, it's going to make it. All right, they have to be similar for them